Alright, now we're on ellipses. So make sure you turn over to those particular charts. And the thing to know about ellipses, or ellipses, or whatever you want to call them, is that in these formulas, a is always the bigger number. It's not necessarily the first thing. And that's different for hyperbolas. Hyperbolas, a is always the first number, whatever's under the first thing. But it's not for ellipses. It's whichever one is bigger. So in this case, what's underneath y is telling me what a is. If you square root 625, you get 25, and that's a. If you square root 400, that's 20, and you get b. I didn't actually pay attention. What are the instructions? Find the center, vertices, and foci of the ellipse with the given equation. So the center is super secret opposite society, so -5, comma, -4. The vertices are, because the bigger number is underneath y, then this is, if you look at your chart with center HK, that's the right-hand column. And that's important to realize that it's the right-hand column, not the left-hand column, because even though it's not, this isn't listed first, the bigger number is underneath y. So my vertices are at h, comma, k plus or minus a. So that's -5, comma, -4 plus 25, which is 21, and -4 minus 25, which is -29. So there's our two vertices. To find our foci, we need to find the Pythagorean relation for a and b. So remember, for ellipses, it says on there a squared minus b squared. So that's 625 minus 400 equals c squared, which gives us 225 equals c squared. So the square root of that is 15. So our foci are h, comma, k plus or minus c. So -5, comma, -4 plus 15 is 11. And then -5, comma, -4 minus 15 is -19. So there's all of that information. Center, vertices, and foci. Number 10, we have to do a little work because this is not in standard form. Standard form has a 1 on the right side, which typically means we see fractions. So we need to divide everything by 36. That's the way to get a 1, is divide by the reciprocal. So that gives us x squared over 9 plus y squared over 4 equals 1. So this is an ellipse centered at 0, 0, because there's no parentheses around x and y. In this case, a is 3, because it's the bigger number, b is 2. So we can find our Pythagorean relation, our c, by doing 3 squared, which is 9, minus 2 squared, which is 4, equals c squared. So 5 equals c squared. So c equals square root of 5. And then we have all the information we need to find the vertices and the foci. So the vertices, since the bigger number is underneath x, the vertices are plus or minus a, comma 0. So they'll be at plus or minus 3, comma 0. And the foci are at plus and minus c, and c was square root of 5, so that's plus or minus square root of 5, comma 0. Graphing the ellipse, there are 3 things to look for. You want to know where the center is, so on this one the center is at 0, 0. And then we want to know about a and b. So a is the square root of 49, which is 7. B is the square root of 9, which is 3. So we put a point at 0, 0, and then we're going to go up and down 7, because that's what's underneath y. We go left and right 3. And then we draw something that hopefully looks more like an ellipse than a rectangle, since it's supposed to be an ellipse. Well, that looks pretty good to me. Then on this next one, it's not in standard form, so we've got to divide everything by 900. And 36 over 900, that simplifies to be 25, I think. Yep, 25. So that's 25 on bottom. And then that'll be 36 on bottom. So the center of this is at 2, 1. And A is 6, B is 5. So you go to 2, 1, but then make sure that you remember that this is going to be up and down 6, because that's what has to do with y. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then left and right 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And draw. Alright, on 13, they are asking us to find the equation in standard form for the ellipse that satisfies the given equation. On this first one, the vertical major axis is of length 18, and so since it's a major axis, it's telling us that A is half as much as that, so A is 9. The minor axis length is 10, so B is 5. The major axis is vertical, which means that that y is the one that goes with 9. If you think about it, you could like try to draw this out, and that might help. That the vertical major axis is 18. So this way we're 18, which means that 9 is going to be underneath y. Now, they don't actually tell us enough information really for us to know for sure where the center is, and because of that we're just going to assume that the center is at 0, 0. And you can write this the other way where y is first instead of x being first, and that's fine as long as 81 is underneath y and 25 is underneath x. On 14, they give us the foci and the major axis length. And so we can use those. The major axis length tells us A, so that's half of 10, so A is 5. And then the foci tells us, since the h's are the same, it tells us h, comma, k plus c and k minus c, and it doesn't really matter which one you make which. If you end up with a negative c answer, just know that that negative will go away when you start squaring it to use it, so that's okay. Now that means h is 3, and you can either, like, there are different ways of doing this, but you could set up a system real quick if needed to find k and c. That would be 2k equals negative 2, which means k equals negative 1. You plug it back in up here to get c, so you add 1 over, c is 3. Once we have c being 3, we need to get b, so you use your Pythagorean relation of 5 squared minus b squared equals 3 squared. So you do 5 squared minus 3 squared, you add the b squared over, and that gives you 16 for b squared, which means b is 4. And now we're ready to go ahead and write out our problem. We've got h is 3, so that's x minus 3 squared, over a is 5, and that goes underneath, since h didn't change, we have a is underneath y. So we put 16 underneath here, y minus k, so y plus 1, and then underneath y is a squared, which is 25, equals 1. This should be the standard form of our equation. The eccentricity of an ellipse, E equals c over a, so we've got to find c and a, and we've got to start off by standard forming this. So that gives you x squared over 35 plus y squared over 5 equals 1. So we know a squared and b squared, so we can subtract them to find c squared. So that gives you 30 for c squared, and c is square root of 30. So we need e equals c over a. So that's square root of 30 over a, which is the square root of 35. And there's not really a lot you can do with this. Well, actually, you can simplify 30 over 35. You can put them under the same radical, and that gives you 6 over 7. And you could rationalize, or you could find a decimal, or something like that. That would give you 42, square root of 42 over 7, and then you could do nothing with that. Alright, problem number 16. A satellite is to be put into an elliptical orbit around a moon. The moon is a sphere with radius of 149 kilometers. Determine an equation for the ellipse if the distance of the satellite from the surface of the moon varies from 891 kilometers to 824 kilometers. Now this problem is a little bit different than what we did in class, because I'm pretty confident that they're suggesting the moon is at the very center and not at a focus. And then that would mean that the shortest distance would be this distance right here, would be 824. And then the farthest distance would be this distance right here, which would be 891. The 149 comes into effect because in order to actually get all the way to the center, we have to add 149 to each of those numbers. So our B for our problem is going to be 149 plus 824. The A is going to be 149 plus 891. Let me get out my handy dandy calculator and figure out what those numbers are. 973 for B, and 1040 for A, and it's centered at 0, 0. So the bigger one is y, so that's y squared over 1040 squared plus x squared over 973 squared, or you could write it in the other direction as long as you put the right numbers on bottom. You could square them, but I feel like that's a really big number that our calculator may not be happy with us about if we try to put that in